we made again. Question number 7. Given that log to the base of 2m equal to p and log to the base of 3m equal to r, express log base m 18 in terms of p and r. Alright, here's the solution. Log m 18 is equal to log m 2 times 3 times 3, right? 3 times 3 is 9, 9 times 2 is 18, so that is correct. And this is equal to log to the base of m 2 times log to the base of m3, and again log to the base of m3, which is equal to log to the base of m2 plus 2 log to the base of m3. But you see, we know that log to the base of 2m is equal to p and log to the base of 3m is equal to r. But we don't have something equivalent to log to the base of 2m and to the base of 3m in our new equation here. But we know that log to the base of m2 is equal to 1 over log to the base of 2m, and this is 2 over log to the base of 3m. Why? Because we know that a formula, I put it aside here, log b to the base of a is equal to log b to the base of c. C can be any constant, and log a to the base of c. Okay, this is a formula that we should know. So that this is equal to 1 over p plus 2 over r. So that's the answer we are looking for. Move on to the next question. Right, given this expression, we are going to express x in terms of p. You can see that x is the index for 2, and then 2p plus 3 is also index. We have base of 2 and 16 here, so we need to make it consistent. We need to turn everything to the base of 2. How do we do that? Let's take a look at it. 2 to the power of x over 8 equal to 16 to the power of 2p plus 3. 8 can be expressed in base of 2, which is 2 to the power of 3, right? 2 times 2 is 4, 4 times 2 is 8, so that's correct. And 16 is equal to 2 raised to the power of 4. So then we can expand it here, 2 raised to the power of x, and then 2 to the power of 3 is equal to 2 to the power of 4, right? And then raised to the power of 2p plus 3, and then we just do this. We just multiply with 2p plus 3 everything in bracket. And you should know as well that this formula, a raised to the power of n divided by a raised to the power of n, that is equal to a raised to the power of m and a to the power of n equal to a to the power of n minus n. So we can apply that to the left hand side of this equation. So that this is equal to 2 raised to the power of x minus 3, which is equal to 2. Let's multiply 4 and 2p plus 3 equal to 8p plus 12. There you go. So let's get rid of the base too, right? So we just take a look at the index. X minus 3 is equal to 8p plus 12. So we need to express x in terms of p. So what we need to do is to move minus 3 over to the other side, so it becomes plus 3. So x is now equal to 8p, and then 12 plus 3 is 15. So that's the answer. Let's move on to the next question. Given the arithmetic progression x, 5 and 7, question A, state the value of x. So we are given the first three terms of the arithmetic progression, and as you know, arithmetic progression has common difference. So now we can write that the common difference d is equal to 7 minus 5, which is equal to 2, and the first term a is equal to x. Question A is the value of x. It is straightforward, right? Because if we are trying to find the value of x, x is the first term. When you take a look at the second term, is 5, while the common difference is 2, then we know that x is 5 minus 2. Which is equal to 3. So that's the answer. B. Find the sum of the first 18 terms of a progression. The formula for sum of the first n term is like this. Sn equal to n over 2, 2a plus n minus 1d. Okay, if you don't memorize this, at least you can refer back to the list of formulas at the beginning of this exam papers, at the first few pages of the exam paper. So for this question, n is equal to 18. So S18 is equal to 18 over 2, because n now is equal to 18. 2a, a is now 3, plus n, which is 18, minus 1 multiplied by d, which is 2. So it is equal to 9. Then 2 times 3 is 6, plus 18 minus 1 is 17. And then we multiply that with 2. So that is equal to 9 times 6 plus 34. 17 times 2 is 34, plus 6, that is 40. So this is equal to 360. So that's the answer. Move on to the next question. Question number 10. The third term of an arithmetic progression is minus 5, and the eighth term is 15. So this is again arithmetic progression, and it has common difference. Find the first term and the common difference. So T3, the third term, T3 is equal to minus 5, and then T8 is equal to 15. Formula for Tn is like this. Tn is equal to a plus n minus 1d. A is the first term, while d is the common difference. So when n is equal to 3, then T3 is minus 5. And then we can apply that formula. It becomes a plus n minus 1. N now is 3. 3 minus 1 d. That is equal to minus 5. So a plus 2d equal to minus 5. So this is the first equation. And then let's do something with T8. T8 is equal to 15. So another one is like this. A plus 8 minus 1 d is equal to 15. So that is a plus 7d equal to 15. So we name this as equation 2. So if we equation 2, we do this. Equation 2 minus equation 1, what will happen? Then we have a, that minus a, that becomes 0, and then 7d minus 2d. 7d minus 2d, and then on the right hand side of the equation is 15 minus 5. So over here on the left, a disappears because a minus a is gone. So left is only 5d is equal to 20. So if we divide both sides with 5, then we get the answer d is equal to 4. Okay, that's the answer for d. If you want to find a, then let's do this. I'm gonna, okay, space is limited, so I'm gonna do it over here. Put d equal to 4. Put d equal to 4 into equation 1. So a plus 2d, which is 4 now, is a plus 2d. d is 4 now, so equal to minus 5. So a plus 8 is equal to minus 5. So let's move 8 over to the right. It becomes minus 8. So now a is equal to minus 5 minus 8, which is equal to minus 13. So that's the answer for a. Move on to the next question, number 11. Question number 11, given this progression, for the first 4 term is given there. X squared, x raised to the power 4, x raised to the power 6, and x raised to the power 8 is a geometric progression. So we know that, and it's given that x is between 1 and 0 exclusive. Sum to infinity is 1 over 8. So formula for sum to infinity is like this: a over 1 minus r. Let's take a look at the first question. The first question is the common ratio of the progression in terms of x. That is quite simple. Common ratio r is equal to t2 minus t1. Then is x raised to the power 4 divided by x squared, which is equal to x squared. So this is the answer for a. The next question, b, the value of x. We can use back the information regarding s to the infinity. Sum to infinity is equal to 1 over 8. So that means using the formula that I stated just now, which is s infinity a over 1 over r. A is x squared, r is also x squared. So we need to find the value of r now. So a is x squared. X squared over 1 minus x squared is equal to 1 over 8. Then we can move about this one on the left. We go to the right, it becomes denominator as well. 8 move to the left, become denominator, become numerator, pardon me. So 8x squared is equal to 1 minus x squared. Moving minus x squared over to the left, it becomes plus x squared. So over here is 9x squared equal to 1. Let's move page down a little bit. So x squared is equal to 1 over 9. So if we divide both sides with 9. So x is equal to square root of 1 over 9, which is plus minus 1 over 3. But remember, the question says that x is between 0 and 1, so it cannot be negative number. Therefore, x is equal to 1 over 3. So this is the answer. Let me put a note there. There you go. X is greater than 0. Next question. Number 12. The variable x and y are related by the equation. This equation, I'm not going to read it. Alright. Where p and q are constant. So it is given a graph. PQR is a straight line there. It's a linear relationship. a cross point P, Q and R. Q is 2, 4 and R is coordinate 4, 0. Take a look at the axis. Y, this is y over x, and this axis is x squared. So that gives us a clue. Question A, express the equation in linear form. So let's do that. So how do you want to turn it into linear equation? Take a look at the denominator on the left is x squared. So we need to get rid of x squared. We need to put it in a linear form. X squared as well. Over here we have q over x. We need to get rid of that. So we need to multiply both sides with x. Multiply that with x. So what happened? On the left, let's push down. Y over x squared times x. Yeah, so that left with y over x equal to px times x become px squared plus q. Because q over x times x, you leave with q only. So this is the linear form. Then we substitute. Let y, capital Y equal to y over x and capital X equal to x squared. So we can turn this into a linear form, become like this. Y, capital Y equal to px, capital X plus q. There you go. Well, this answer above is quite good already. It should give you full marks. But you know, I just substitute with another two sets of two variables so that it really looks linear. Then find the value of P and Q. We're given a graph there, so and we have this axis y over x is now capital Y, and this is capital X. We have just now equation of y equal to px plus q or minus q? Plus q. So we are given two coordinates there. So information there is enough for us to go and figure out the value of p and q. There are two ways to find the value of p. So let's take a look at a simpler one. Let's go find the gradient of this graph over here, because p, this is equivalent to the form of y equal to mx plus c. M is the gradient of the graph. So in this case, p is the gradient of the graph. And it passes through 2, 4 and 4, 0. So p is equal to the gradient of the graph, which is equal to at the side here, let me put the equation for the gradient. y2 minus y1 over x2 minus x1. So p now is equal to 4 minus 0 over 2 minus 4. So that is equal to 4 over minus 2, which is equal to minus 2. So that's the value for p. And then q. Let's take a look at the point R here. Let's substitute the value. P is known. At 4, 0, at coordinate 4, 0, then y let's use back the equation just now. Y is 0 equal to px. P is now minus 2. X is 4. plus q. So q is equal to 8. Alright, because this is minus 8, so if we move it to the left, it becomes 8. So that's the value of q. Alright, let's move on to number 13. The vertices of triangle are A 4, 7, B H 3, and C 10, minus 1. Given that the triangle ABC is right angled at B, calculate the possible values of H. Let's visualize the graph so that we understand, so that we know how it looks like. So this is, say, point A is 4, 7, roughly here. 4, 7, and then point C is 10 minus 1, perhaps around here. And then we have point B, H3. We do not know whether or not. Let's put that in red. And remember that point, it is right angle at point B, so it probably be here. It could also probably be somewhere here, alright? So it could be anywhere there. All we know is that if they are right angle, then the product of two gradients is minus 1. Such that m1 times m2 is equal to minus 1. So let's say let m1 be, let m1 be gradient of line AB, and m2 be the gradient of line BC. Do you have enough space? Let's take a look at it. Okay, we have some more space. Then m1 is equal to, remember the formula of the gradient, which is m is equal to y2 minus y1 divided by x2 minus x1. So m1 now is 7 minus 7 is taken from coordinate A, y-axis, y coordinate of point A. And then the y coordinate of point B is 3. So 7 minus 3 over 4 minus h. So h is not known. So m1 is equal to 4 over 4 minus h. And m2 is equal to minus 1 minus 3 and over 10, which is the x coordinate of point C, minus 4 minus h. Okay, this is minus 4 over 10 minus h. Alright, then you don't really have enough space here, so let me get rid of a few stuff. Let me just delete the graph here so that I have enough space on the right. Remember, m1 times m2 is equal to minus 1. So then 4 over 4 minus h times minus 4 over 10 minus h, that is equal to minus 1. Alright, so this minus 16 over 4 minus h times 10 minus h equal to minus 1. So we can get rid of the minus sign at both sides of the equation. And if we turn upside down on both sides, and you know, on the right, 1, if you turn it upside down, then it still become 1. And Okay, let me just get back. Let me just backtrack a little bit here. Okay, minus, we can get rid of it, and then we can transfer 16 over to the other side, so it becomes 1 minus 16. And then I would like to turn everything upside down, so this becomes 16 over 1, and this one is also upside down, become now the denominator become numerator, so then it becomes 4 minus h, 10 minus h equal to 16. So let's go and open up the brackets here. So 40, and then minus 4h and minus 10h become minus 14h, plus h squared becomes 16. Then let's move 16 over to the other side, it become minus 16. Minus 16, alright, there. So h squared minus 14h, and then 40 minus 16 becomes 24, equal to 0. Then we can factorize. Okay, space is really short, so h over here 24. We need to find the product of 24, probably 12 times 2 and minus sign on both sides, because then minus 12 times minus 2 is plus 24, and then h multiply with minus 2 become minus 2h, and then minus 12h become minus 14h, so that is correct. So then h is equal to 12 or h is equal to 2, so that is the answer. Two possible values of h. Let's move on to number 14. Well, we'll move on to number 14 in the next video, because I like to keep the video short. Below 30 minutes if possible. See you later.